So something I forgot to address in the previous two videos. If you have a vector v here and a vector u here going in the opposite direction, would these two vectors be the same? So I forgot to address this in the previous two videos. So this is your initial point, your terminal point, your initial point, and terminal point here. So the vector itself would be terminal divided take away initial, so that's u moving in the positive 3 direction, and then terminal take away initial, that would be u moving up 2, so that would be u moving up 2. And but for this vector, it would be -3, -3, and -2. The question is, are these two vectors the same? In your mind, when given something like this, in your mind, move this vector here to so that it starts at the original. So that it starts at the origin. Sorry. So it starts at the origin, and move this vector here so that it starts at the origin as well. It starts at the origin as well. Now, in order for the two vectors to be the same, in your mind, move this so that it starts at the origin, and then in your mind, move this so that it starts at the origin. Now, for the two vectors to be the same, these two must match up, but they don't. These two must match up, but they don't. So these two are not equal. So I know I asked you to look at the gradient, but that's only good when everything's positive. But to do it technically correct, move everything so that it starts at the origin, move this so that it starts at the origin, and then compare these components. If these components match up, then you can say, if all components match up, then you can say they're equal. Suppose this is -1, then and then this is -3. These two match up, so it's good. But then if this is -1 and this is, let's say, 2, then you can say that the two vectors are different. You can extrapolate this into 3D as well. So in 3D, if you have in 3D, it's hard to illustrate on a flat 2D surface. But in your mind, if you in 3D, in your mind, move this so it starts at the origin. Move this so it starts at the origin, and then if you have another vector, if you have another vector, in 3D that is. So let's say this is u1, u2, u3, because it's a vector. Hang on. In 3D, move this so it starts at the origin. Move it so it starts at the origin, and then look at the three components. So looking at this, so v1, so for this one here, it would be v1, v2, v3, and then move this so that the origin so that it starts at the origin. So looking at this point, it would be u1, u2, u2, u3, and then compare these. All three components must match up. It must match exactly up in order for you to say that this vector is equal to this vector. Okay, so you can't just compare it straight away, but try to gear your mind into moving this to the origin. Move this so it starts at the origin. Even in 3D, try to move it so it starts at the origin. Okay.